Good morning everyone. In this particular video lecture, we will discuss some numerical questions based on the concept of capacitance. Now my dear friends, the first question is, as you can see here, a capacitor has a capacitance of 5 microfarad. Calculate the stored energy in it if a DC voltage of 100 volt is applied across it. Now my dear friends, as you can see here, first of all we will write the given data here, and as you can see here in question, the value of capacitance is given, and that is equals to, we can say, 5 microfarad. And as we know, my dear friends, for the conversion of microfarad into farad, we have to basically multiply by 10 to the power minus 6. Now my dear friends, as you can see here, the value of voltage given is 100 volt. Now for the calculation of a stored energy, we use the formula energy is equal to, or we can say work is equal to, integration from 0 to t p dt. And my dear friends, we also know that the value of p in case of capacitance is equal to cv into dv by dt. And now my dear friends, as we will put the value here, as you can see here, it will comes out to be half cv square. Now my dear friends, as we will put the value of capacitance here and the value of voltage here, the amount of we can say stored energy is comes out to be 2.5 into 10 to the power minus 2 joule. This is basically our answer. This is basically, my dear friends, our answer. Now my dear friends, the next question is question number 2, and as you can see here in figure, the voltage time profile of a source to charge a capacitor of 50 microfarad. What is the charging current? Now my dear friends, as you can see here in the given question, there is a graph um, in between voltage and time. This is basically versus voltage versus time graph. And as you can see here, we have to basically here in the question, the data is given regarding the amount of the value of capacitance, that is 50 microfarad. And my dear friends, as you can see here, for the calculation of current, as we know, its value is equal to c into dv by dt. Now my dear friends, the value of capacitance is given, but only we have to calculate the value of dv and dt, means change in voltage and change in current. Now my dear friends, according to this graph, if we want to calculate the value of change in voltage, that is dv, then as you can see here, the voltage is changing from 0 to 20. So the value of dv, that is change in voltage, will be 20 minus 0, that is 20 volt. And my dear friends, if we want to calculate the value of current, that is gt, then as you can see here, the current is changing from 0 to 10 millisecond. So my dear friends, if you want to calculate the value of dt, then it will be basically equals to 10 minus 0, that is 10 millisecond. And my dear friends, for the conversion of millisecond into second, we have to basically multiply with 10 to the power minus 3. So so the total amount of time will be 10 into 10 to the power minus 3 second. And my dear friends, as you can see here, the value of capacitance here given is in microfarad. So to for the conversion of microfarad into farad, we have to basically multiply with 10 to the power minus 6, as you can see here. So the total amount of capacitance here is equal to 15 to 10 to the power minus 6 farad. And now my dear friends, each and every data for the calculation, each and every data required for the calculation of current is ready. And now basically we have to put all these value in this formula. And as we put all these value in this formula, the value of current will comes out to be 0.1 ampere. Now my dear friends, the next question, that is question number 3. Now in question number 3, we have to basically find out the equivalent capacitance. As you can see here, it's very simple that the series combination of both these capacitor is in parallel with these 2 microfarad capacitor, and the whole combination is in series with 1 microfarad capacitor. Now my dear friends, as we can see here we have calculated the equivalent of the series connection. And then my dear friends, as you can see here, after calculating the equivalent comes out to be 1 microfarad. And as you can see here in this figure, these two combination are in parallel, and and the whole equivalent capacitance value is in series with this 1 microfarad. Now my dear friends, the next as you can see here, we have calculated that capacitor between the value of capacitance between x and y. As you can see here, we have calculated the value of capacitance between x and y. Now my dear friends, the equivalent of both these two will comes out to be 3 microfarad, and as you can see here, this 1 microfarad is in series with 3 microfarad, and the equivalent capacitance will comes out to be 3 by 4 microfarad. Now my dear friends, the next question is as you can see here, find the equivalent capacitance across x and y. Now my dear friends, in this question we have to find out the equivalent capacitance between terminal x and y. Now my dear friends, first of all we have to note it down that as you can see here, my dear friends, as you can see here, first of all we have to deal with the capacitor C1, C2 and C3. Now my dear friends, as you can see here in the given figure, that the series connection of C1 and C2 is in parallel with C3. So here as you can see here, we have calculated the capacitance equivalent to C1, C2 and C3. And my dear friends, now if we will talk, then the whole one will be in series with capacitor C4. The combination, now my dear friends, the combination of C1, C2 and C3 will be in series with capacitor C4. So if we want to calculate basically the amount of equivalent capacitance, now as you can see here, C equivalent to, now my dear friends, here we have denoted the equivalent capacitance of C1, C2 and C3 will be equal to C equivalent 1, and if you want to calculate the C equivalent 2, then it will basically comes out to be C4 into C equivalent 1 by C4 plus C equivalent 1. Now my dear friends, as you can see here, the C equivalent 2 basically includes C1, C2, C3 and C4. And my dear friends, from this combination we can see that the C equivalent 2 will be the C equivalent, as you can see here, the C equivalent, now my dear friends, as you can see here, the C equivalent 2 will be in parallel with C5. So in the next we can see here the C equivalent 2 and C5 are in parallel, so the equivalent will be equals to this one. So the equivalent will be equals to this one, and as you can see here, we have denoted it by C equivalent 3. Now my dear friends, if we move further, then we will see that C equivalent 3 and C6 are in series. So we apply the series formula, and then we calculate the equivalent capacitance by the combination of C equivalent 3 and C6, and it will basically comes out to be this one. And now my dear friends, as you can see here, the whole amount that is the equivalent capacitance will be equal to this one. And after calculating all these things, the equivalent, after doing all these calculations, as you can see here, the equivalent capacitance value will comes out to be this one. Now my dear friends, the basic funda regarding this one is to understand the connection. First of all, what we have done here is we have to calculate the equivalent by the combination of C1, C2 and C3. Now my dear friends, for calculating the equivalent by the connection of C1, C2 and C3, we can see here C1 and C2 are in series. So first of all, we will calculate its equivalent, and then my dear friends, its equivalent will be in parallel to C3. Then we will calculate the equivalent by the combination of these three one, and then my dear friends, the equivalent of all these three resistors will be in series with C4. And then further, my dear friends, the equivalent of all these four resistors will be in parallel with C5. And lastly, my dear friends, if we calculate, then the equivalent of all these 5 resistors will be in series with C6. And this will basically will be the value of capacitor, or we can say the value of equivalent capacitance between the terminal X and Y. Now my dear friends, in the next video we will discuss regarding the energy sources. That's all. Thank you.